I'm over on my workbench, my real kind of mechanical assembly soldering workbench, and I do have a power supply, so I can do testing too. But today I'm focusing on the smoke system to test our puff and chuff brake and idle software circuits thing. Okay. What I wanted to show you was the smoke system that I'm using, and then this notion of lids for the smoke and what I call smart smoke. And you can see here, Andy designed our lids for us. Smart smoke 2022. And we have two versions of these, what we call lids. This version, as you can see, is for the standard Flyer cast metal smoke, which has a piston that goes in and out, and that makes the puff, and that makes the chuff sound. Actually, it has a little Weezer baffle thing in there that goes, and it sounds like chuffing of an engine, kind of. And then the smoke comes out here. So what this board does is it regulates the temperature of the heater that makes the smoke. And I'll explain how and what that is. This is a later version. Well, no, it's just a different version actually. But here you can see we've added a little opening where the Weezer can make its noise better, more louder. And we've tested some others, and that seems to work. So anyway, that's that version for the standard smoke. And this is the lid for the smoke that I've designed over 3 years ago, maybe 5. This is many variations later. Been a long time coming on this. But this is a 3D printed housing, and it has a reservoir. It has some rock wool material just down in there, and that absorbs oil, and it will just be a reservoir of oil. And how we get the oil up is we use what's called angel hair. This is sort of like glass fibers in a fiber, and we dangle it down into that reservoir, and it runs up to the top. And then the top is in contact with a resistor that happens to have a lot of resistance, and it gets hot with low voltage. So this will get hot, and what it does is it gets the oil droplets near it and actually vaporizes them, or evaporates them, and they turn to smoke. So this whole housing here with this lid on top will fill with smoke. And then, as you can see, there's a hole in the back that goes straight through. You can see my finger, okay? It goes straight into that smoke box. And there's a fan that will be put together and show you how that works. And it will blow air through the smoke box out that tube, and that tube runs into this opening, and that becomes the output of the smoke for the stack. So this seals the lid. The fan blows the air through. This heater that you see here, that's a heater coil. It will get hot and make the smoke oil evaporate. Smoke builds up in here, and when it puffs, smoke will come out the top. And every time the motor puffs, and this is the motor, exact same motor we had over in our demo. It's a small, what they call mini DC can motor, and it has, it can do forward and reverse. It doesn't have a built-in brake, but we've created that by passing a negative and positive at the same time to the fields, and it just sort of freezes. So it'll go and then freeze, freeze, and that will be the puff. Puff, stop, no smoke, puff, smoke, stop. Okay, so that's puff. Now the chuff is a sound, and that's digital, and that's a whole together different. We had to separate. This is puff and chuff, and it's mechanical. We had to separate it. When we went to the digital fan, we had to separate the chuff sound out. It's digital, and it's through a PC board. Now, get to that later. Anyway, what I had to do with this particular unit is I had it built some time ago, and it had some older pieces on it. It had a resistor here that was a fixed value, and it had an older smoke that had a much higher ohm reading and required a lot of voltage to get to the heat. And it's coated with a ceramic, almost like concrete, and I had to scrape some of that off to make it work effectively. But it was semi-insulated, it ran hot, and on and on. I had found, and this is a Lionel part, by the way, one of the problems I had was it's wider than the part I found in the supply store. So if you see this looking a little pooched out in the cheeks, it is because I had to make it wider. I had to pooch it out to make room for this wider heater. But this heater has a lot of advantages. One, it's very inexpensive. It's $2.50. And it's coil wound, so the heat is right out there. The internal component is a heat-resistant material. So it's a resistor, but it's made to be a heater. This is a resistor that we use as a heater. It's not really designed for it. This one is, so that's good. Now, the other component that you can see it here, that little gold orangey thing. There's one in every one of them. And that is a sensor. The gold orangey thing is a temperature sensor. And it measures the temperature on and around the heater. And the advantage in that is, first of all, very early on, I didn't have the smart control as well. And this would take off. People would hook up track power, 18 volts at full speed. And this thing would get we use these guys, they would get so hot, it would actually melt the 3D printed part. And they'd call me and say, oh, it's all melted down, Dennis, it doesn't work, and send it back. And I'd ask them, what did you plug it in? What power did you use? Oh, I used transformer power. Okay, well, you can't do that. I told you, you can't put more than 9 volts to it. And a transformer goes anywhere from 15 to 20 volts. So that's, it's going to melt. So we came up with a few things. First of all, we came up with a PC board. Let me see if I have one. And I do. This is a purchased item. It's about $2, and it's called a Buck Boost board. And it has, here you can see in, and here you can see out. And in is the DC power after it's gone through a regulator. It's been converted from AC to DC. And that DC power from the track comes in. So it's 0 to 17 volts coming in. But it has parts on here that allow it to manage the power so that it only sends out 8 volts. So if I have 5 volts here, it sends out 8. If I have 10 volts here, it sends out 8. If I have 15 volts here, it sends out 8. If I have 17 volts here, it sends out 8. Constant 8 volts. Terrific. 8 volts goes in here, and our circuit is tuned for 8 volts. Now there's variations when this thing gets assembled, and we always needed to tune it. I did pick on a particular resistance, and it was like in the range, but I quickly learned I really needed a variable resistor, and this is called a trim pot. You can actually use a little screwdriver and rotate it and change the resistance inside the box, which is great because you can tune it. Now you notice this has all kinds of things sticking up. This is for development exercises, okay? They don't look like that when I'm done with them because they have to be, as you can see here, they have to be flat to fit. And even this thing's in the way. So I've relocated it. You'll see in a minute. So now what I'm going to do is assemble it. And I don't think I can do this online, but I'll just come back and show you when it's built. So this fan goes onto this stem here. I don't know if I can do it with one hand. Kinda, okay. And then the motor fits in there, but how does it mount? Well, now I jumped the gun. Before I put that on, let's see if I can get it off. Almost. Come on, baby. There we go. I get it off. Oh, whew, okay. This is engineered to fit in that opening just like that and bolt on. And it's airtight. And the motor is designed... Uh-oh, bad motor. I got to get a different motor. It doesn't have the screw holes in it. At any rate, it will bolt in like this. And it has a little hub. You can see that gold or copper hub. That's designed to fit exactly into that circle there. So the first thing you end up doing is you screw that into the hub in the center, not off center like it is, through these tiny holes on the side, right by my thumb. I have little watch screws that go in there, and they screw into the motor. But not that motor. It doesn't have the screw hole. Then when it's bolted in and it's squared, the stem sticks out enough that you can push this guy down on. And we learned some time ago that we might have to trim these blades. But that's not a problem. It just pulls off and pushes on. So I can put it together. We can try it with the full blades. And then if we need to change it, I can pull it off and change. I can put on a new piece if I have to. This is called the motor adapter plate. That's the motor and that's the fan. This is the smoke housing. And the fun part about this, the thing that I like the most, is how the air flows here. It's a closed system, so with the fan, it has to have some air it can pull in and then push out through the opening to push the smoke through. So the inlet is the very center hole, and the outlet is the very upper hole. So what the fan does, as it rotates, it creates pressure to the outside. It pushes the air to the outside. And when the air is pushed out to the outside, as it gets to the top where that hole is, it escapes. And it flies into the smoke chamber, which has a lid, and it just flies straight in, and it pressurizes the smoke chamber, and the only way it can come out is through that hole there, and that hole there brings it up here. So as it builds up its pressure, it's creating an airflow straight across and up. Now, if it didn't have that hole in the center, it wouldn't be able to pull air in, or suck it in, you might think. And where does that go? It goes to this side opening right there, and there's one on either side. So it can pull air in from the side like a cyclone. It comes into that center hole. The fan is whipping around. It compresses or pushes the air to the outer edge. It pulls it in the center and then pushes it out. And if you put your hands over these while it's running, the smoke will stop. Really cool. So the fan's running, sucks air in, compresses it, pushes it out, blows it through this hole. The heater's hot, the oil is evaporating, there's smoke filling. When the fan is given a puff, it goes puff, smoke pulls out. Then it stops as a break. Airflow stops, puff, stop, that's puff and chuff. Okay. And the temperature depends on the amount of airflow. So the slower you're going, that 8 volts can get pretty warm here. And as it gets warm, that thermistor realizes, hey, I'm up about 300 degrees or 200 degrees, whatever it is, and it tells this processor chip here, cut back on the voltage, I'm too hot, and it will turn on the resistance and bleed some power off, and the heater will cool down until it reaches the proper temperature. The thermistor cools off, and it lets go of that signal, and then the heater will start building up heat again, and it will sit there and go like in between the zone that you want. And the trick is, at slow speed, like at idle, you don't need much heat, so the temperature down here is probably 5 degrees. But when you get chuffing and puffing, if you go faster, and you're going like flat out 90, 100 miles an hour, you're puffing smoke, that fan is just constant going. That heater will get cold. That cold air is coming in, and it'll just take the heat right out of it. Well, when the sensor realizes it's getting too cold, and we're not at the temperature we need to be to evaporate the oil, it will say, hey, Chip, wake up. I need more juice here. And it will crank up the power. It'll send more of that 8 volts in, and the thermistor makes the heater get hotter, and it'll get hot to the point that the maximum temperature that we can handle, and we adjust that in our setup from this chip here. We set the maximum power here. we set the minimum power on this one. I'll get back to that one later. So it's puffing and chuffing, the air is flowing, I'm cooling down, more voltage. Okay, here comes more. Oh, I'm heating up again. The evaporation continues. We're puffing, smoke's coming out nice. We slow down. Whoa, I'm getting hot. Okay, cut back the voltage. Cuts back the voltage. The smoke stays about the same. It might decrease slightly, but the temperature will be approximately the same. And as the volume of airflow drops, the smoke coming out is separated between the puffs and has more time to cool down, blah, blah, blah. So this stays alive. It doesn't get overheated and melt. The smoke isn't wasting oil from smoking at 900 miles an hour and just burning it all out. And you can adjust it. You can adjust the peak smoke here and the minimum smoke here. This is the trim pot that we put in. And what I've done, because we have such a tight fit on the top here, I put it on the bottom. And it fits. Look at that. Okay, fine. I put some markings on it because when you're trimming it, it's hard to see. But there's a little blade in there, and that's just like a screw tip. And you would put a screwdriver in there, and you could rotate it. Let's see if I can find one. I'll show you what I got here. I get my tool out. Here's one here. This one will work. I think this one will work. So this is the tip, the two dots. Where am I? Right there. Okay. The two dots right there is the tip of the adjuster. And this line that I drew here is midway. That's halfway. Now, I'll see if I can do this and you guys can watch. As I rotate it and stay in focus, as I rotate it this way, you see that? I'm increasing the resistance. If I go this way, I'm decreasing the resistance. Now, decreasing the resistance will give it more voltage. And what you'll be doing, you'll do this while it's running. You'll have it running, and you'll sit there and say, I'm low speed now. Okay, you're at low speed. And you can adjust this up and down from midway. I start at midway, and then I go up or down. More smoke, less smoke. And I get the smoke where I want it at low speed. Then I run it up to full speed, and I sit over here, and I adjust this one until I've got where I want it for the high speed. Those are the two adjustments, and between the two of them, the smoke will manage the temperature and the amount of smoke that you get out. Now we use this hair, call it angel hair. I thought I had a thinner piece. There I do. What we do is we take some of this, that's probably too thick, but we wrap it around this heater coil a couple of times, and then we pull it tight, and then we shove it down below, and we shove it down into that rock wool. So it's like wrapped around, but then it's hanging down in here, and it will wick that up. We assemble that. We do all of that, and we cram it in like that, and then we set this down. We put an adhesive all the way around. It's like a gasket sealer, and we screw that down so it's airtight. The wick is hanging down in the rock wool, and it's wrapped around the heater, and the air will flow over the heater and cool it down, carry out the smoke, and we can adjust. Once this is assembled, we can adjust our temperatures and set it up on the bench over here, and then we say, okay, we got it. Between these two pieces, we know what we have, and we then take it and put it on the engine. Now, the smoke part, as you saw, was engineered to fit that engine. It just bolts on. Now here's an engine that did have the metal smoke. As you can see, there's a recessed hole there and a upright hole there, and that's where the smoke would fit. Well, the smoke I have is different. It's just like this, so it doesn't fit. There's no way to put it on, really. So I use my 3D printer, and I build what I call an adapter. So the adapter fits in here just like that, and it uses this hole and this hole to mount that down. But before I put that down, I screw the adapter onto the smokehouse like that. Boom. So it'll screw into those holes, and then it will screw onto this piece, and it'll look just like that, so that the opening is at the exact same spot as the stack on the engine. And I take that dimension relevant to these mounting holes here because they keep that all the same, the Flyer guys do. So if I stick to that, I'll be okay. And then I just make from here to these holes where I have to put my smoke housing. Now there's another style engine that Flyer made, and it was called a reverse boiler. This one did have a smoke and boiler. It's taken off. This one did not have smoke and boiler. It had the reverse unit, so it never had smoke. This poor engine could never smoke. And engines were made to smoke. Now, ours almost fits there, but there's nothing to hold it down. Well, again, I go back to my 3D printer and I design something that will hold it on. It slides over the end like that, and then it snaps down. Oh, this is for a different engine, but that's okay. It'll be okay. You'll get the idea. And then it screws down into those holes there. It'll screw down into that hole, and it'll be captured by this bent over tab thing here, and that'll lock it in place. And of course, before you do that, you bolt this down. And again, that dimension here is the key. Make sure it's the same as the one that Flyer uses, and you're all set. Not sure what this is for, but it's not this engine. Sorry about that. But I have several variations of the adapter for that reason. So this smoke can fit on any Flyer steam engine chassis. And this smoke bolts on like that. It takes 8 volts to run it, and we have a volt regulator that we provide, and it's a buck boost. It'll boost up low voltage, and it'll buck down high voltage. So it'll be 8 volts coming in, and you adjust it when you get it all set up, and that'll run the smoke. And that's what I'm going to be doing now the rest of the day. I'm going to be putting my fan motor together, find the right motor, assemble the fan motor, put it in, and I do a spin test. I turn it on. I use the battery, and I turn it on, and I make sure the fan's not hitting anything with any resistance. I make sure I have good airflow, and that's good. You test as you assemble. That way you don't build crap. Okay. Then I'll get this buttoned up. It's not fully soldered, but the heater needs to be soldered down. Then I can make all those final adjustments. I have to make sure the heater is in the middle of the cavity and not on one side or the other. Looks like it's a little close to the right. I need to move it to the left. And it's in the center of the cavity, so it has a lot of air gap around it, so it doesn't get too hot. And then I'll put the gasket material around it. I'll wrap the hair, dip the hair down, pack it, put this over the gasket material, put in the screws, tighten it up, and it's done. Let that cure for a little bit, put the motor in, and then I'll come over here and I'll put 8 volts to this baby, and I'll put a little button with the power supply to the fan, and I'll sit there and play with the button, and I'll say, okay, here's idle, and adjust the smoke for that. And then here's full speed. I'll just hold the button down and let it fly, and I'll adjust the power for that. And that gives us our coarse tune. When you're on the engine, then you tune it for that engine. Whatever that engine's giving it in the way of volts and airflow and all that, you tune it for that engine. But these 2 adjustments are done on this one will be in the tender, this one's in the chassis. And you do it with the body off, and the tender body off, and the body off, so you can get to these things. Tune it that way, then you assemble it. It should be okay. So that's what I'm doing with the smoke. That's how this smoke works. It's not like the old smoke, but it's different, and it's something that we created because we had to, and it's worked, and it's really cool, and we like it. And we put it on these engines that don't have smoke, never had smoke, or we put it on engines that had smoke, but you can't get the other smoke, or you want the puff and chuff. Now that we have the real brake and the chuff sound, that's more exciting, a lot more exciting for these older engines. And we're going to be putting this one on Leon's engine, which did have smoke, so we're adapting that. and I'll be putting it on, I believe that other engine that I have over there never had smoke, so we're going to be using it. Oh no, it has a gear, so it had smoke. Anyway, it'll have the same adapter. Anyway, you'll see variations of this as things go on. It'll be fine. So I'm going to build it, send it. If I need to, or if it makes sense, I'll show you a video at the end, let you know. Oh, and on the Puff and Chuff, the relay, which takes 3 amps and up to 20 volts or something like that, I've ordered a 1 amp 3 volt, which will fire as soon as the transformer is turned on. It'll fire, and that will give us the proper sequence of operations over there on the puff and brake test system. And I ordered 10 of those. I didn't ask them what happens if I feed it 10 or 15 volts, but I'm hoping that's okay. I might need to put a resistor in there, but we'll see. I'll ask Robert, he'll know. So this is what I'm doing today. I'm building a smoke system, and this is one that we've had for a long time, but it's really refined now so that it works well. It doesn't heat up. It doesn't overextend your oil, and it's tunable and adjustable, and you will see it in action here in a short minute. Okay, later. Thank you.